Okay, welcome back. This is section 2.7, the quadratic formula and the discriminant. In this section, we are going to use the quadratic formula to solve some quadratic functions. And we're also going to learn how to recognize when a quadratic formula is going to give us a complex solution. And then we will be writing them as a plus bi for any of those real numbers. Okay, so remember our quadratic formula? Hopefully you have memorized it from Algebra 1. If not, now is a great time to do that. So let's go ahead and remember how we use quadratic formula. So we have it already in standard form. Remember, all quadratics must be in standard form because before we can utilize the quadratic formula, ax squared plus bx plus c must equal 0 before we can utilize the quadratic formula. So here a is 4. B is negative 12, C is 9, so we put that in. Negative B plus or minus the square root of B squared, which is 144, minus 4 times A times C, so 4 times 4 times 9, all over 2A, which is 4. And so simplifying here, we have 12 plus or minus the square root of 144 minus 144. Well, that's convenient, all over 8. Well, 144 minus 144 is just 0. So we have x plus or minus. Square root of 0 is just 0 over 8, which is 12 over 8, which reduces to 3 over 2. So we really only have one solution here. One real solution of 3 halves. That's kind of cool. All right, let's try another one. So in example 2, we're not in standard form, so we subtract 3 on both sides using our inverse operations here. So we have 3x squared plus 8x minus 3 equals 0. Good. All right, now we can go ahead and identify the a, b, and c. So a is 3, b of course is 8, and c is negative 3. And so let's see, negative b plus or minus the square root of b squared minus 4 times a, which is 3, times c, which is negative 3, all over 2a, which is 3. Okay. Simplify that down, negative 8 plus or minus the square root of 64 minus plus 2 negatives, so plus 4 times 3 is 36, all over 2 times 3 is 6. So we have negative 8 plus or minus the square root of 100, all over 6. So bring that back down here. So negative 8 plus or minus the square root of 100 is 10 over 6. So really we have two equations here. So we have x equals negative 8 plus 10 over 6. And we have x equals negative 8 minus 10 over 6. So negative 8 plus 10 is 2/6, which reduces to 1/3. And over here we have negative 18/6, which reduces to negative 3. So we actually have two solutions here, right? Two solutions. And that would be 1/3 and negative 3. All right, let's try one more. Still not in standard form. All right, let's go ahead and put that in standard form. So inverse operations, subtract by 4x on both sides, add by 15 on both sides. I'm going to do this all in one step. All right, so now we have x squared. Remember, keep it in standard form. Minus 4x plus 15. And 0 is left on the right-hand side. Fantastic. All right, so a equals 1. B is negative 4. And c is 15. All right, let's do this. So negative of negative 4 is 4 plus or minus the square root of b squared. So I'm just going to go straight to 16 if that's all right with everybody. Minus 4 times a times c all over 2a. So now I have 4 plus or minus the square root of 16 minus 4 times 15 is 60. Uh-oh, that's not looking so promising. All over 2. So this is going to give us 4 plus or minus the square root of negative 44. all over 2. Square root of a negative number. Well, luckily, we already know how to deal with that. We're just going to rewrite it as 4 plus or minus I square root of 44. There we go. And we remember that we can reduce those radicals. 44 is just 4 times 11. So the square root of 4 is 2. So I end up with 4 plus or minus 2I square root of 11 over 2. And every single term in this fraction is divisible by 2. So we divide by 2. 2 divided by 4 is 2. Or sorry, 4 divided by 2 is 2. 2 divided by 2 is 1. 2 divided by 2 is 1. And so we're left with 2 plus or minus I square root of 11 all over 1, which of course we can just write as the 2 non-real solutions that it is. Let's not write it like that. Let's write 2 plus or minus I square root of 11. There's no reason to leave it in its completely imaginary state. All right. Okay, so that was a good review of the quadratic formula. And we got some interesting answers. We got 2 real answers, right? We got 1 real answer, and then in the other example, we got no real answers, but 2 imaginary answers. And we can actually predict based on just the equation what kind of solutions we're going to get. And that answer comes from the makeup of this quadratic formula. It's not really magic. It's kind of math magic because it's pretty smooth the way that it works, but it does actually have a reason. Remember, when we have a fraction like a plus b over x, really that's like a over x plus b over x, right? We can split that fraction up, basically divide everything in the numerator by the single denominator. So we can actually rewrite the quadratic formula as 2 different fractions. We generally just write it as 1 because it's more convenient that way. But we can think of the quadratic formula as negative b divided by 2a plus or minus the square root of b squared minus 4ac all over 2a. And I hope some of this looks familiar. This should look familiar. This is the axis of symmetry. Okay, so really, when we're looking at the quadratic formula, we're really getting the axis of symmetry, and then we're using something to figure out where the zeros are, right? This is kind of telling us about where the zeros happen to be in relation to our axis of symmetry. And so if we split up the quadratic formula, again, officially, so we get our axis of symmetry from this first bit, right? Negative b over 2a. And then we get this square root of b squared minus 4ac over 2a. And the part of it that becomes important, right? When we had 1 real solution, what was under your square root? 0. And when 0 is under your square root, you're adding and subtracting 0. When you have a negative number under your square root, we know we have an imaginary or complex solution. And when we have a positive number on our square root, we know that we're going to have to add and subtract something. And so this discriminant becomes a very important discriminating factor when it comes to the number and type of roots that we have, the number and type of roots. So let's explore that. So when we had 1 real root, that meant that our axis of symmetry went straight through our 1 real root. And when our axis of symmetry went straight through our 1 real root, then when we look at our quadratic formula, what was under the square root had to be equal to 0 because we're just at our axis of symmetry. We don't need to go anywhere else. There is nowhere else to go. And so our discriminant was equal to 0. When we had 2 real roots, we went through our axis of symmetry, and then our roots were on either side. So we had to add and subtract something to our axis of symmetry, which meant our discriminant had to be a positive square root so that we could actually take a real number from that. When we have no real roots, we have our axis of symmetry, and then we're adding and subtracting imaginary numbers, which means the value under the square root has to be negative. And so we can use this concept of b squared minus 4ac and determine its sign to determine how many roots we have. So when b squared minus 4ac is less than 0, so that means it's negative, you get 2 imaginary roots. When b squared minus 4ac is equal to 0, we end up with 1 real root. And when b squared minus 4ac is positive, we end up with 2 real roots. Now, those real roots don't necessarily need to be positive. They could be on the left side of the y-axis, but this gives you a good visualization of what we're looking at. Okay, let's do a practice problem. So first, always standard form. So let's add x to both sides and subtract 5 from both sides. So we have negative x squared plus x minus 5 equals 0. Now it wants us to find the number and type of solutions first. So we can go right ahead and use the discriminant first to determine the type of solutions. So b squared, so here in this case, a is negative 1, b is 1, and c is negative 5. Okay, so for the discriminant b squared, so 1 squared minus 4 times negative 1 times negative 5. So we get 1 minus, because a negative 4 times negative 1 is positive 4, times negative 5 is negative 20, so we end up with negative 19. And so we know right away, since the discriminant is negative, we have 2 complex or non-real solutions. Okay, so we have 2 complex solutions. Now let's find their exact equation. So we're going to go ahead and use the quadratic formula. So negative b plus or minus the square root of, we already found negative 19, right? Because we already found the discriminant, it's right here, all over 2a, so 2 times negative 1. So we have negative 1 plus or minus I, square root of 19, all over negative 2. I don't like leaving negatives in the denominator. So I'm going to, you can either multiply both numerator and denominator by a negative, or you can just leave it like this, that's fine. So you can either write it like this, or it's 1 plus or minus I square root of 19 all over 2. So you can do it that way also. Both of these are equivalent because when you add and subtract, it doesn't really matter which way you go. Okay, so just to recap, we found the discriminant over here, right? This is the discriminant. Then we described the type and number of roots, so we use the discriminant to describe. Then we found the exact solution, so x equals 1 plus or minus I square root of 19 all over 2. Okay, so let's try this one. So subtract 3x from both sides. So x squared minus 3x, no, there's no constant. What does that mean? I have to add 0. Okay, so plus 0 equals 0, so that means a is 1, b is negative 3, and c is 0. So let's go ahead and find the discriminant first. So b squared minus 4ac. So b is negative 3 squared minus 4 times a times c. Well, anything times 0 is going to be 0. So negative 3 squared is just 9, so my discriminant is 9. Since it's a positive discriminant, I have 2 real solutions. 2 real solutions. And now I can go ahead and find the exact value using the quadratic formula. So negative of negative 3 plus or minus the square root of the discriminant, which is 9, all over 2a. Negative of negative 3 is positive 3, plus or minus square root of 9 is 3, all over 2. So x equals 3 plus 3 over 2, or x equals 3 minus 3 over 2. So I end up with x equals 6 halves, which is 3, or x equals 0 over 2, which is just 0. So the solutions are x equals 3 or x equals 0. And those are my real solutions. Okay, so if you want some more examples, go ahead and watch the More Examples video. Otherwise, please go ahead and complete the 2-7 quadratic formula and discriminant reflections. Up next, make sure to watch the quadratics and rate of change video. Thank you again for listening.